go to a short lab 3, to upgrade your C++ version, and then I'll stay here for question to make sure your compiler works, because the next project you want to make sure that you want to start compiling using VS Code. All right, what's files? So files is similar to how you use terminal for C and CL, where files is a storage of data in memory. So when you do C and CL, when you use terminal, the minute that you finish your program, it's gone. Right? Whatever you have in the terminal, it's temporary. Where files, it's more of a storage of data that will persist instead of stream or buffer that are temporary. So the way that we C++ look at files, it does not consider it any different than the terminal. We're C++, right? For us, it's different because files is going to be persistent. You can open it afterward. It's completely isolated from your program. Files, though, for C++, completely the same. Okay, no different for C++. You just think of it as a place to store or to transmit to or transmit from. For the files for C++, it will need to recognize the end of the file, which is what we talked about last week, end of file marker, right? So it's the same thing that C++ used to determine this is the end. Some behavior of C++, when you open a file with your program, a file object will be created. We'll show you how. In addition to the file object, the stream, similar to the buffer that you see in C and CL, is created in association with the file. It's linked. They're linked together. If we look at the stream, right, which is the buffer that we've been pointing out on the slides, it has been acting as an intermediate channel between your C and CL and your terminal. Similarly, for files, stream will be using as the communication channel between your program and a file. That's the only difference, is that for C++, it just swap the terminal with a file, that's it. Okay? Therefore, the library that we're going to be using, also different. The one that we have for input-output is IOStream. For file, we have a library called AppStream. However, we also have 2 additional libraries. One is OFStream for output, IFStream for input. Why is there 3? AppStream can be used for both input and output. In extreme cases where you're really trying to save memory, you don't want to have 2 buffers, right? One for input, one for output. You could share one AppStream, use it for input, output. However, for this class, we will not be dealing with big data or anything like that, so you can use OFStream and IFStream, one for output, one for input. One thing to note, if you want to use AppStream for both your input and output, is that you then need to tell your program what you're using it for. There's a mode that we're going to talk about later. If you set the mode to output, you cannot use it for input. Okay? So you have to specify what mode you want it to be. But for OFStream and IFStream, you don't need to, right? OFStream is strictly for output, IFStream is strictly for input. So that's a convenient thing for that you could use for OFStream and IFStream. So we'll draw the stream similar to how we did for C and CL for this test one. All right, first thing we're going to look at is writing. Overview of the program we will be looking at. It's very simple, 5 lines of code. Make sure that you have AppStream included if you want to use both. Right? So, but for this example, I only use OF. But if you have AppStream, you can use OFStream or IFStream or AppStream. Right? Use all 3. So I normally just include the AppStream so that I have the flexibility to choose what stream I want to use. For this one, I use OFStream for writing, and this will create an object and then I will link the file, I will write to the file, and I will close it. Okay? The note about this example is that the first time you run this, it will create a new file for you. Alright? This is only when you don't have one that already exists. So if you already have one, it will overwrite. If you don't have one, it will create one. Okay? So let's look at it in detail on what's happening in memory. The first thing that I did is create out an OF stream called my file. Right? So at the bottom, that is the space that you're allocating. It's of type stream, but it's an OF stream, so strictly using for output. The name of this memory storage space is called my file. Okay? So if you look at the code, this syntax is no different than int I, float f, string s, right? Type name, right? Similar. The type OF stream name my file. So you can change it however you want. You can change it to different name because it's just a name that you're creating to name this OF stream that you will be using. Next, line 7, myFile.open. So myFile.open, it's calling this OF stream object function open to open a file and link. Okay, so that is why we don't just call open. We call myFile.open, meaning that I'm opening a file in associate with this storage. So what does that do? That is saying that when I insert into my file, right? So insert into the stream, similar to cout. I insert hello with a space, world with some exclamation point, and then new line. I insert everything in there. The minute I have that, because they're synced, I will also have that. Okay? So that is writing to a file and what's happening underneath. Make sure you always close your file so that your memory is not taking the space to hold the file open. When you're done, you close it, you free that up, and then you return 0 at the end. All right, any question on this short example? Perfect. Now let's look at modes. There are, this is a list of modes that I screenshotted from the C++ documentation that I showed you last week. So you can find exactly this on the documentation page. The FStream object has many modes. So when we are looking at the .open function, in the previous example, we only had .open here, and then we close the parentheses right here, right? But there are also other parameters that you can put in. If you put comma, the second one, you can have modes. So what do they mean? You can use modes first to indicate whether you're using it for input or output. Alright? This is why I was saying that if you have FStream, you need to specify a mode, because your computer will not know what are you using the FStream for. But if I use OFStream, in my previous example, I did not have any mode, right? Because I don't need to. When you have OFStream, we know that, oh, we have IOS out, which is the second line of the mode, by default. So I don't need that. So that's input and output to specify how you're going to use that stream. And then here are some other specifications of how you're going to read and write. There's open in binary mode. We're not going to use that. However, we will be using the following three. The first one is where do you set the initial position? This, when you have, so you can see the mode here, when I have ISATE, we actually won't use this, but when I have the ATE, it will set the initial position at the end of the file for you to write. which is similar to APP, which is append. That's really popular, right? People use that all the time. Is that I don't want C++ to overwrite my file if it exists. I want it to append to it. Then you just do ls append in your mode. There's also this ls truncate. If the file is open for output and it already existed, its previous content is deleted and replaced by the new one. This is actually also by default the behavior of CI, of OF-stream, right? It's when you're writing to a file, the file already exists, there's something in there. When you're doing it again, it's going to overwrite. So if you don't want it to overwrite, make sure you have ls append. Okay? Here's an example of how I can have more than one mode specified for your OF-stream. So this one, I have ls out, which is not necessary because I have OF-stream here. But if you have f-stream, you need to have it. And then you can have a second mode with this bar here, have ls append for this example. So this time when I write this, it will append to my file instead of overwriting. Right? Okay. So here's an example that for you to go back and try out. The first example, after running, you should have an example.txt file created. Now, where will that be created? Whenever you run your program is somewhere in the location in the folder, right? There's a concept called current running directory. That is where your file, where your running program is located. So say that my main.c++ is located in the folder CS37. It's another folder called file. That is my running directory. When I have a file open, it will be in the same directory of where my program is at. So the minute that you run the previous example with no mode, you will see in the same directory a file called example.txt created after you finish that program. Now the second time you run this, right, where you have the append mode in the program, you will have a second line appended at the end of the same file, example.txt. Okay? All right. Normally, I can demo and run and show you exactly what it looks like. But I tried and my computer will not connect. In the recording that I posted, you will see me try to demo it. I may bring another computer next time. Hopefully, that computer I can demo live coding so you can see, you can test things, and then you can see how I run, how I debug. But yeah, today I couldn't get it working. So yeah, so this is kind of a screenshot of what the file will look like. The first time you run it, it will have one line. The second time you run it, it will have two lines. Okay? All right. This is where we talk about the default mode. When you have f-stream, it doesn't have any default. Okay, so when you have OF-stream, you have ls out as the default mode. Can I still add it? Sure, you can still add it. It won't do anything, but like I had in my previous example, that's an OF-stream, and I have to move out. It won't error out. IF-stream has the default mode, ls in. Okay. Oh, by the way, you have noticed that we are using another namespace. iOS, column, that's a new namespace. Right? So yes, we do have other namespaces that we use. But can you still use using namespace std at the top? Yes. When you have using namespace, that means this is a default namespace for all my programs, unless I specify otherwise. So when I do iOS, it will swap. It will go into iOS, it will try to find out and in from there, not from std. All right. The other default mode for we talked about is truncate, right? Where whenever you don't have any mode and just write to a file that already exists, then it will overwrite. So that's the default behavior. If you want to change that, you need to make sure that you have append, iOS append. All right. We on the left, we have this, right, where we create a stream, call my file, then we link an actual file from your computer to that stream so that they're synced. So whenever I do line 8, it will directly write into that file. This is such a common pattern. The minute that people create a stream, specifically app stream, they are linking it to a file. Right? Otherwise, why do I use an app stream? I use app stream because I want to link it to a file. Therefore, in this equivalent example, you can combine those two lines into one. Right? So this is saying that I'm creating OF stream, call my file, and link it to example.txt at the same time. Right? Now, I have seen people linking it twice, it will break your program. Remember that if you are using this version of OF stream or IF stream, the same thing, that you link your file and move on. You don't want to have line 6 over here and then have line 7 over here. That will not work. Okay, so you either break it into 2 lines, you create a stream, and then you link it, or you combine it into 1 line, you create a link at the same time. Right? Okay, so a couple things that you want to note when you are using files or working with files. The first thing is check file opened. C++ will not tell you when your file failed to open. It will just run as it's been running successfully without telling you until you finish 300 lines of code and you have realized nothing was done. Okay? This happens a lot. And then you have 300 lines of code. Which line went wrong? Right? So we never want our program to do anything silently. We want it to tell us if something goes wrong. For files specifically, you need to check. So every time you open a file or you attempt to open a file, you want to check for file open. So this is an example of when a file will not open. File will only open, will only be created if it's in the current directory. So for this one, I do not have a folder named test, and I also do not have a file named example.txt. Your computer will not create a directory for you at the same time create a file. Not going to happen. C++ will only create a file for you in the current directory. If there's no such folder, it'll just be like, move on. Line 10, write to nothing. Line 12, close to nothing. Line 14, return 0. And you're just kind of miserable. Okay? So, how do we catch this? How do I know whether a test folder exists? You probably won't know. Therefore, in our program, we want to make sure we have a stage, right? This is your responsibility as a software engineer. It's not to assume, oh, it's going to be fine. I'm going to put it in a folder. There's going to be a task subfolder in there. My user is going to do exactly what I tell them to, and they're going to run my file perfectly. No, never going to happen. Okay? As a software engineer, it's your responsibility to make sure your code can run in chaotic environment. And believe me, there's many chaotic environments out there. So you need to check. You need to be the one that be like, oh, I'm going to open this file in this directory. Wait a second. Let me double check whether that actually exists. So the good way to write files is that you open it, and the second line right after you open it, you check. Okay. At line 11, I'm going to check if my file dot is underscore open. Alright? OFStream has even given you a function to check it. All you need to do is trigger that function. Alright? But a lot of people forget about this, right? Especially at the beginning when you first deal with files. You will forget to check it open, you will forget to close it. So I want to make sure that you always remember to open and close. Therefore, there's a rubric in my project saying that did you check your file open? Alright? So make sure you check your file open before you do anything to the file. Otherwise, you could just silently. Alright. So we went into one example where if the folder does not exist, if the directory does not exist, it will fail, right? Is there any other ways that it will fail? Yes. There are read and write permit for each of the files on the computer. If you're trying to read or write a file that you don't have access to, like you either don't have read access to or you don't have write access to, it will fail silently. It will not tell you and be like, oh, I cannot touch this file, moving on. Okay. Similarly, when you're trying to open a non-existent file for reading, right? When we write, yes, it will create it because we're going to write to it. When you read, system is assuming that you have the file already exists there for you to read from. If you don't, it will just move on. Okay? When you're opening a file for writing, but you have no disk space to write it at, that will also make it fail, right? You're trying to write it, meaning that you're going to store it. You better have space at your computer to store it, which I believe most of you will have. But this is another scenario where you would go into a no disk space, right? You know, you're all thinking that, oh yeah, that's never going to happen. Yes, because you are the one who owns your computer. You're the only one who works on your computer. When you go into industry, that's not the case anymore. You most likely have a shared server out there where somebody from your team decided to fill all the space and you have no space whatsoever. If you don't have the if statement, you don't even know who to yell at. Okay, so check the if statement and see that, oh, it's not writing or it's not opening. What's going on? So those are all the scenarios, probably there's more, that a file could fail to open and it won't tell you. Okay, you need to make sure that you check. Closing a file, you see me close in all my examples. It's very important because this is another small techniques to make you distinguish from software engineer and a good software engineer. You always need to manage your memory space. Okay? You make sure your program is efficient. You don't want to be the one who write a software that makes everyone's computer make fan noise. Right? You don't want that. And if you take up all your memory spaces, I guarantee you, when people will click open and you run your program, the fan just gonna go crazy. Please don't be that kind of software engineer. So memory will be free up when you close your file. Okay? So always be mindful when you're programming. But you will be like, well, when I return 0, isn't everything's gonna be free up? Yes. I can't guarantee that I will not put your program in a while loop that runs 1,000 times. I mean, that won't do good to my computer. Like, you can't guarantee someone else won't do that, right? So always remember to be cautious on what memory space you're using. Can you free it up? Can you save it? All right. To help you practice that, I have another rubric that's saying, did you close your file? So please remember to close your file when you run your project. All right, reading. So this is our example for reading. You can see that it's really similar, right? Where we have I as stream. Now I'm putting into one line because you learned how to do that now. I have I as stream for input, call my file, example.txt, that's what I'm going to read from. I have a local variable string line. I'm checking whether my file is opened, right? and then I'm going to read from it. And the way that you read from a file is basically the same thing that you're reading from Cn, right? You have a memory space that you're inserting into this variable line, which is a string. And then I'm going to print that out to make sure that I have what I need and close the file. Remember the file that we were working with where we have hello world again. But when I do this, when I run this example, right, I'm opening the whole file, which is the example.txt. I have a string called line, which should be able to hold all the hello world and the new line. I open the file, I read it in, but when I print it, I don't have hello. What happened to the rest of my line?
Because the line is changed after the space.
Because the limiter, yes. Yes. So when we are, look at memory again. When we have a stream, my file example.txt, the minute that we open it, it's going to link to your file, right? And then in that stream, you will have the contents from the file, which is hello space world new line, which we have. You have your line, and then when we read from line, it's going to do exactly the same thing when you did it from Cn. It's going to parse it. It's going to try to understand every single character and parse it for you. Meaning that you can read integer, you can read double, you can read string, because it will be able to parse those types. For the string, like this, it will just check, is H a string? Yes. Is E a string? LLO a string? Oh, space, the limiter. I'm going to pause. I'm going to wrap everything I have so far. I'm going to save. Remember that? Right? Exactly the same as Cn. Therefore, all you're going to have is hello. Right?
Show me the deadline for this.
Exactly. Less than ideal. I don't just want to crop my first line. I want to have the whole line of hello world. What do I do? Yes, we use the same thing. Get lines. Yeah. So remember when I show you get line, I specifically did not put IO stream there. I didn't mention it. I just said stream. Are we working with streams? We're still working with stream. So this function still works. Right? So all you need to do is you use your getLine function. Instead of doing instead of doing Cn, you just do my file. Okay? So that's the only difference that I made, which is this line. Instead of doing my file, insertion operator, and then the file, I did getLine my file. Okay. So getLine will do what? getLine will make sure that you read everything until new line, which is what I want. So now at the bottom of the output, I have hello world. Yeah? All right. But my file has multiple lines, right? We have 2 lines. Do I write getLine, 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 getLine? No, right? We always want to be careful on writing hard-coded code. So what we're going to do, we're going to have your program to try to understand the file until it reaches end of file marker. Okay, so we learned the file marker last week about that used to signal the end of Cn. And then we talked to you about how Cn is so similar to IF stream. Yes, same thing, right? The while loop will run this condition of getLine until it reaches end of file marker, which is actually at the end of file in the name. Okay? So we're going to have this while loop. We'll have this while loop. It will run until it finishes getting all the lines from my file. And then it will break out the while loop and it will close. Very convenient, right? Now, when I have this in my while loop, this is get line, my file, line. Meaning that every time this while loop runs, this local variable line, we override it. Okay? So don't assume that, oh, I have my line.
Save.
I have it saved somewhere. Nope, not at all, right? You can see this function being triggered right into the same variable from line 9 over and over again. So the second time this while loop runs, the first line is gone. You don't have anything. Right? So be careful when you're doing something like that in a while loop because you don't preserve those local variable values. Now, how do I know that? Like I have so many variables in my program, and I don't know. I'm like, do I need to be very specific on, oh, this is going to be overwritten every single time? You have your debugger. So all you need to do is put a red dotted breakpoint over here. When you trigger it, you could see it. You could see it live, be like, oh, okay, my line is different now. So yeah, this is when I want you to start relying on your debugger more and more, because that really helps you to inspect your program. All right, the things after the slide, you may not be able to run right now. This is C++ 14 features called Moded. And they have changed it every single semester. So if you run this example and tell me you couldn't run, please let me know. They may have moved the quota somewhere else. They have been moving it every single semester, super annoying. But hopefully they find a good place for quota so they stop moving it. So hopefully this will work. You have to have C++ 14 to run quota. And I will show you how to upgrade your C++ in lab 3. Now, why do we specifically pick this out and talk about it? Because this is really helpful for you to parse a file. A lot of the time, you don't write to the same file that you read. You're reading a file that someone else put things in there that you don't have control on how it's being formatted. You will be like, oh, ideally, I want you to put an integer first, and the space, and the float, and the space, and then you put a string last, so I can nicely parse it. Yeah, right. So, the way that we try to group strings together most commonly is the double quotes. And then for C++, it can help you read everything inside quotes if you use this function codec. So for this one, this is someone gave me a file that they have 307, they have double quotes of first and last name. Nicely formatted. I want to read the first one as user ID, and I want to read everything inside quota as username. Okay? So if I just similarly go into my file and I read it, right? I have my local variable, integer ID, string name, check file open, read ID, read name, close. You won't have it. You will have 397, you have double quote J, that's it, right? Because the space here is no different than the space here. Both of them are considered as delimiters. Your parser will stop, wrap, store, move on, okay? Which is less than ideal. So how do I do it? From last semester, they decided to move quota into IO manipulator. So make sure you include that library. This time, IO manipulator, so that you can use quota. Otherwise, you won't be able to run it. Simple as use this function quoted with where you want to save the quoted contents into. So my name is a string, right? And I want to save the quoted information, which is first name, space, last name, the whole thing, into variable name. Therefore, I just put quoted name. Okay, everything else the same. I read from my file ID, then quoted name. So now I have Jane Doe as my username. You also have noticed that the double quotes are gone. So it's smart to know that, oh, you only want the things within the quotes. You don't want the quotes. Therefore, it will remove the quotes for you and just grab whatever is inside to store it in your variable. All right? What about writing? Right? When you write, yes, you can do the same thing. If you put quoted on the variable with the contents you want to write, it will put the quotes around your content for you. So here's a comparison between when you just have name with a tab, ID tab name, versus ID tab quoted name. By the way, the name is this variable. You will have two different lines. ID space name, ID space quoted name. Okay, so you can use quoted for both reading and writing. That's it for AppStream. Okay, so I have mentioned a couple of things that I've seen people doing in their project assignment. One, if you want to use AppStream, you need the mode. Okay, if you don't want to use AppStream, you can use OSStream and iStream. You do not need the mode. Okay. Second, if you are creating a file, you link it once and once only. All right. If you link it twice, it's not going to work. Then for file, after you open it, always check whether it's opened. I'm just going to say it now. It was supposed to be hidden in my project assignment. Every single file you need to check. No matter whether you're opening it for reading or writing. A lot of people lost point because they check when they open for writing and then they forgot to check when they open for reading. Whenever you open a file, no matter what you're doing, just open in a file, check. Check right away. Okay? All right? Are we ready to know what C++ version you have on your computer? You need lab 1 for this. Yes, question?
Is it possible to open multiple files at the same time? So like one for input, one for output to like log what you're doing?
You could. They have to be different streams. You cannot use the same app stream and make it 2 files at the same time.
Okay.
You can have one stream for input, one stream for output, separate.
Okay.
Then you can do it. But one single stream can only be with one file. Alright, so you need lab 1, meaning that you need to have at least VS Code installed. Then you just need this simple program. Okay. You need to run this. When you are writing this single line, there are 2 underscores. 2. I know it looks like one big one. Nope, 2. Okay. Underscore underscore C++. Train it. You will get your version number for your C++. While you're typing, just want to talk about typing speed. Speed does not matter. Okay, so for the
You
people
can't show off with it.
for the people who be like, oh, I type slow, it's fine, right? You know what really tells the difference in an office when you have a bunch of software engineers around you who's typing? You cannot tell who type faster. You definitely can tell people who type aggressive. Aggressive typer, and then calm typer, which I really like because we all use really loud keyboards. So if you type slow, you're fine. What you want to care about is what you are typing. Okay. So are we all done typing this? You're all done, right? All right. Once you run this, you will have a number like this right now. First four number mean the year. Second number mean the version. You need to be above 2014. If you are already above 2014, have a good night. I'll see you next week. A lot of you will have 1998 or 7, 1999. Okay, new versions now. A lot of times people just have 1998. But if you have anything below 2014, we have one more slide. We're done typing this. Can I move on? You have this on Canvas as well.
This is on Canvas?
This is on Canvas.
Yeah.
Lab. It's under the lab. So the first module, lab 3.
Under the first one?
So let's go to code preference setting. For the Windows user, it will be file preference setting, but find settings.
Literally the second module.
So to the lab 2?
Find your settings.
No,
yes,
lab
question?
3.
So I got the number higher than that. Is that okay?
That's fine. Yes, as long as you have above 2014,
Okay.
you're fine. Okay. We go to settings. Now, in the settings search bar, which will show up in the middle of your screen, type executor. Then you will have an option at the bottom saying executor map. And there should be a link here, say added in settings.json. If your interface have an option for you on the top here where you have a user and a workspace, maybe a folder, make sure you pick user. Okay? Because sometimes it could default to workspace, sometimes it could default to folder. You pick user, meaning that the setting that you're setting up for, the next time you come in, even say it's a different folder, it will persist. All right. User added in settings.json. Okay, once you click that, a file will show up. Now this file will look something like this. Some of you may have a blank file, which is okay because if you type code-runner.executor-map, it will have a drop-down list for you to select. You just make sure you pick the code-runner-executor-map. You click that, it will auto-populate for you. Then you have this file. So same thing. You may already have it, or you need to populate it. So after you populate code-runner.executor-map, find C++. In C++, you will see our terminal command, right? So if you look at this, do you understand it now? CD into a directory, right? And G++, run the file name output, file name without extension, and then finally run this file name without extension. So that's exactly the 3 steps that you're going to run from terminal. At the second step, I want you to add in a flag. So whenever in a terminal, when we add dash something something, that's flags, right? I want you to add in a flag called -std. I want you to set the flag value to be C++ version. Once you have that, save this file. Very important, save it, save it, save it. Save this file and you can close it. Now go back to your program, run it again. You should now have 2014-02. Okay? You should save this. You should save users. Under users, settings, save, close it, run it. Yes?
Are we just changing the label, or does it already have the most recent version and we're just telling it to use it?
Exactly, yes.
Oh,
When you
okay.
install, if you have a Windows, remember there are so many things you install, not just one. you have a lot of things installed. By default, some of the computer defaulted to be the newer version. That's probably some of you have 2017. But a lot of computer by default to the oldest version. So what we're doing is that, hey, I don't want to use that. I'm going to use a newer version, which is 2014-02. That's why you don't need to install anything. You just set it up. It's like a setting thing. Once you have that, you should be able to run all our examples from the lecture.